Today I'll be discussing the continuity correction for discrete random variables. So if I have a discrete random variable, we'll say it's a binomial distribution, and it looks like this, there are times that I might want to approximate that with a continuous distribution function. And here it would look like this, a nice normal Gaussian distribution function. The reason I might want to do this is because when I'm looking at continuous distribution functions, we know that we can just integrate under the area under the curve to find the probability that a certain outcome might occur. And those mathematics are often easier than dealing with discrete mathematics. So it can be a really useful tool to do this. But when we do that, we actually have to make some sort of continuity correction. So it's a correction for moving from a discrete random variable and trying to approximate it with a continuous distribution function. So there's rules for that. You see that in certain cases you'll have to add a half, certain cases you'll have to subtract a half, and you could go ahead and memorize these or write them down and refer to them often, or we can just go and understand why these continuity corrections are written as they were, and you won't have to rely on that little cheat sheet. So this is if I have a discrete random variable, and if I start out with this, then I'm looking here at the probability mass function of it. But then when I approximate that with a continuous distribution function, here it's a nice normal bell curve, right? I have the probability distribution function, right? They show me the same things. They sort of show me the same things. Those areas of that are high on the curve represent those points on the curve that are high represent points of high probability. But remember, when I'm looking at a continuous distribution function, I'm looking at areas, not just a point. So we're really concerned about areas under the curve, so we have to estimate our discrete distribution function with areas, and we can do so like this. Okay, so now if we're looking at the outcome 4, for example, right here, and we want to find the probability that x is equal to 4, right? If we're looking at the area now, we're going to be looking at the area of this rectangle right here. And we can see then that this rectangle actually goes from 3.5 to 4.5 instead, right? So we're looking at, instead of just the probability of x equals 4, when we're moving to a continuous distribution function, we want to say what's the probability that x is between 3.5 and 4.5. And then what if instead we're looking at the probability that x is less than 4? Then what do we want to find? Here's 4, right? And we want to find the probability that it's less than 4. So we don't want any of this area. We want everything below that. So instead of using the probability of 4, we're using 3.5 because we want below this point. So instead of this, we'll write what is the probability that x is less than 3.5. Well, what if we instead want the probability that x is less than or equal to 4? Okay, now we want to include the bar that has 4 here, right? So we want everything below here. So that would be 4.5. So now that we want the probability that x is less than 4.5. Okay, 2 more examples. What if we want the probability that x is greater than 4? Then we don't want to include 4 again, right? But we want everything greater, so that we're going to include the probability that x is greater than 4.5. Last example, what if we want the probability that x is greater than or equal to 4? Then we're going to find the probability. So here's it's equal to 4, right? Greater than or equal to 4, we have to go down to 3.5 now, anything here and up. So we want to find the probability that x is greater than 3.5. And those are all where we get all those probability rules that I showed on the last slide. So here's one example you can use to check your understanding of this. If I'm approximating a binomial distribution with a normal distribution, and I want to find the probability that my outcome is less than 7, but greater than or equal to 3, what continuity correction should I use? You can go ahead and pause this video and then continue after you've got your answer. So if I drew my discrete distribution function like this, yours could look a little different than that. It doesn't matter. We'll get the same thing. And I want to find now the probability. Oops, let me put in my continuity curve. I want to find the probability that x is less than 7. So I don't want to include this block where 7 is, right? I want to do below that. So on this side, I'm going to have 6.5. So x is less than 6.5. And on the other side, I want x greater than or equal to 3. So I want to include this whole block that contains 3, right? So I want to move down to the 2.5 side here. So this would be the continuity correction that I would use when I'm estimating a discrete random variable with a discrete distribution function with a continuous distribution function. So hopefully you got, let's see, what answer was that? Hopefully you found that this is answer D.